Welcome, everybody. So as the lecture would imply, we're going to be talking about problem solving today. With programming, the way you approach a problem matters quite a bit and how you end up solving the problem or whether you solve the problem at all. Typically, when you just Google problem solving, you'll find something like this first image where it's define the problem, generate new ideas, evaluate and select a solution, and then implement. I think all of you should know by now that when you're programming, you can't be that vague. And also that's not a great way to approach the problem. So we're going to discuss a different strategy to kind of break down a problem so that it can be parsed into code, and then that code can be actually readable by the computer and solve whatever your problem is. So before we dive in, we're just going to go ahead and get a practice problem to work off of. I know this is a really simple problem, and some of you might have already seen it, especially if you're in my part-time cohort. But we're going to walk through it step by step. The same steps work on a more difficult problem as well. And then finally, until we get to the coding section, don't jump ahead and just code a solution. Most of the problem solving is not code dependent. It's finding that solution and then translating it into code. So you'll see that we can go pretty far and get an actual solution before we actually type any real code. So step one, believe in yourself. You can solve the problem. You can break it apart. You can find the answer. If you don't believe in yourself, even though I know it sounds hokey, it ends up with you giving up early. It ends up with you not having the perseverance to reattempt and fail, and then reattempt and fail. So please make sure that you feel like you have the confidence to do it. And I mean, it's really just about breaking it down into smaller steps. So we're going to start with read the problem for understanding. Understanding what the problem is actually asking is super crucial. So rephrasing the question and understanding what are the finer details of it is super helpful for being able to tackle the problem correctly. So in the question thread, could I get some restatements of the problem that we had so far? Anybody want to give it a go? Not a problem. Can't prepare. So, so when we have this problem of listing out all the natural numbers below 3 or 5 and summing them, we can restate it as find all the multiples of 3 or 5 below a given number and then add all those numbers together. We might also be able to change that up and restate it as just iterate over all the numbers between 1 and n. N has to be above 1 or equal to 1, just simply because that is what the definition of a natural number is, and then add up any of those that are evenly divisible by 3 or 5. And then finally, we can also just simply sum the multiples of 3 below n. Then we repeat that same process for 5, and then we remove any overlapping values and add those summations together. This is super important because, as you can see, there's different things that can be teased out from that. So we'll start with what's the expected input. Maybe you want to take a guess at what we think the input would be. So what is the thing that is that we can change to get a different answer. So, yep, Matthew has it. It's a positive number, a given number. So we know that we have some number. And then what are the properties of that number? Matthew already gave one of them, which is it has to be a positive number. Any other properties associated with that? Anything else special about natural numbers that might indicate? So, yep, integer. Anything else that we might want to know about it? So one other thing we might want to know is that we're looking for the numbers below n, so it's non-inclusive of the number itself. Being able to define your input, make sure that you can solve the correct problem. You'll find in programming that there are a lot of off by one errors where you forgot about inclusivity or exclusivity on the problem. And so it's adding in an additional number or not adding in that final number. And then we can do the same for the output. So what's the expected output that we might see? Any guesses as how our output will look? So it's not going to be a list of numbers because we're doing a summation. So it's going to be one number. It's going to be an integer. Is it going to be positive or negative? And somebody just got it, which is it's going to be another positive number. And then we might want to also specify a minimum for it. So anybody take a stab at what we might think the minimum possible value would be? And it's 0. And then next question we want to ask ourselves when we're breaking apart this problem, restating the problem, is can I just break this into smaller chunks? Is there something about the description that allows me to approach this in a simpler way? And so anybody want to take a stab at some of the smaller chunks that we can solve on this problem? So first is we can find the multiples of 3 below a given number. We can find the multiples of 5 below a given number. What else can we do? Yep, so Charles has a good strategy, which is break up the line that you wrote up here. So depending on how you wrote it, will determine how you break that up, which means that we can also find the sum of those numbers. Anything else that we can break out of it? All right. So moving on. And Matthew is jumping ahead. We are definitely going to be looking at that, which is, are there any restrictions on what I can do? So one of those restrictions is going to be that we want reusability because we're giving just some random number in. So we want it to be a function because we don't want to repeat ourselves. We don't want to be copying and pasting. Are there any other restrictions on what I can or cannot do that might indicate what our constraints are? So One way to figure this out is to try and do edge cases. Another way is, if this was obviously a code challenge, you could ask for additional feedback. So do we have an upper limit for the given number? Are we optimizing for efficiency or just simply trying to solve the problem? All of those things we can kind of ask about and figure out what are the constraints. The better we understand the constraints from the input to the output to any more arbitrary ones, the more likely we are to actually solve the correct problem. And then finally, when you're restating this problem, you should also be thinking, have you seen a similar problem? Why? Because you've probably already solved this problem before, or it might offer clues as to how to solve it as we continue on. And also, you just don't get points for solving it in a new and novel way that nobody else has solved. If the screwdriver already exists, don't invent something new to turn that screw. Instead, just go to the toolbox, grab that screwdriver, and solve the problem that way. So we're going to start iterating through our problem now that we've defined it and we know what the expected inputs and outputs are. And the simplest way to do this is you start really, really basic and you scale up. We're just going to step through, find any patterns along the way, find any change points along the way. So what is the simplest number I can give as n? Which is n equals 1. So what's the answer going to be for n equals 1? So n is divisible by 3 or 5. It's not, so it's going to be 0. So what's the next smallest step I can take? Next smallest step is going to be 2, and I know this is going to seem really simple, but as you build up, you're going to see that it starts to kind of build up the same step-through process that the computer would take. And then what about 3? What's the answer for 3? Yep, still 0. Again, because we already specified that it's not inclusive of n. So we want everything below n. And then what about at n equals 4? What happens there? So at 4, our answer actually does change. The reason for that is that we actually have a number that's divisible by 3 or 5, which is 3. And so our answer is now 0 plus 3, which just obviously comes out to 3. So we can keep on stepping through, and we're eventually going to get up to the next breakpoint where it changes again, which is at 6. And what does the answer become at 6? Yep, so the answer becomes 8. So now we have a multiple of 3 and we have a multiple of 5. And so then we sum those together and we obviously get 8. So are there any other points at which the behavior might change? That's the final step we need to ask when we're stepping through this process. Because if you don't understand when the behavior is going to change, you might end up with an issue where you're solving for just part of the problem and there's an edge case that isn't being solved for. So can anybody think of when this behavior might change slightly? So Valerie had almost the correct guess, which is it changes at 16 because it's non-inclusive. So at 16, we're going to get something that's a multiple of 3 or 5. And in this case, it's both. And so we have to now ask ourselves, how do we handle something that is multiple of both of them? The question doesn't outright specify, and depending on where you're getting this question from would alter the answer. If it's 3 and 5, then we might have to go ahead and add the number twice. We might have to add the number once and basically drop the duplicate, depending on how we're solving it. And so in this particular case, we're going to go ahead and just only add the number once. And so at 16, our answer becomes 60. Now that we have our process, which is we iterate through all the numbers of n, and we check whether they're a multiple of 3 or 5. If they are, then we add them to the answer. Now we can go ahead and take the steps to actually write that out. Again, we haven't used any actual code yet. So what would be the very first step when we go ahead and just talk through what we just did? So maybe starting at 1, look at every integer below n. What else can we do next? So what would be the next step? So we have our number that we're looking at. What are we going to do with that number? Which is, we're going to go ahead and check if it's a multiple of 3. Yep, Matt, you got it. A couple of you got it. And then we're also going to check if it is a multiple of 5. And then what are we going to do if it is a multiple of 3 or 5? What are we going to do with that number? How are we going to sum it? What are we going to add it to? Or so we're going to add it to a running total. And then when do we stop? So we keep on adding these numbers. How do we know that we've arrived at some sort of answer? Yep, so once we reach n, we're going to go ahead and stop, and we're going to have an answer, which is our total. Is there anything else that we might need to do? Anything we left out? So we have, so depending on how we solve it, Ashley is correct. We would have to remove overlapping. We might also want to validate input. For such a simple code challenge, we're not going to validate input, but it is definitely something that might be a consideration. So we have a running total. What does that total start at? So again, the computer is very, very needy and requires you to be very explicit about what you're doing. So we want to make sure that we're defining every last little step. And so next up is we're just going to go ahead and simplify this. I've already done it, and we're just going to go ahead and walk through it a little bit. So we're going to set our total to 0. Then we're going to look at the numbers in the range of 1 to n. We're going to ask ourselves, is the current number a multiple of 3 or 5? And then if so, we're going to add that number to our total. And then finally, we know that total is the answer. Again, we're just kind of breaking this down as we had stepped through it before. we're putting that into words and then kind of condensing those words and slowly transforming them into pseudocode. Pseudocode is just, it's code, but it's made to be readable by a human. So it doesn't take the parentheses and like colons and semicolons and stuff like that nearly as seriously, obviously. And it's probably your last step before you actually start coding. And we can see that we can do it here, which is we translate set a total to 0. We set it to 0. We look at numbers in a range 1 to n. And we know that we're going to eventually have to write the code, so we might want to set that up to be pretty similar to how Python handles a for loop. And then we're going to ask ourselves, is it divisible by 3 or 5? So we're going to go ahead and do a check to see if it's divisible by 3, divisible by 5. And then if it is, we're going to go ahead and set our total, add to our total. And then finally, at the end, we're just going to have an answer. So at this point, no matter how complex your problem is, you can still be doing all of this pen and paper, whiteboard, in your head, depending on the complexity of the problem. And then you would finally go ahead and translate that pseudocode to code. So does anybody want to translate that into actual code for me? So first part is pretty simple, which is obviously total equals 0. And then we're going to go ahead and translate our for loop to be a little more rigid with parentheses and our values. And then go ahead and write our 3 equals 0. 0. And then finally, we want to output that. So at this point, are we done? So we've written code. Hooray, we're done. We've solved the problem. Maybe you want to give me an opinion on whether we're done with the code or not. Obviously, from the notebook, you can probably guess the answer. So first step is obviously run the code. So we run the code, and it's going to connect for a second. And we have a naming issue. So next step is to debug and refactor, just kind of clean up your code. So we're going to go ahead and do that real quick. So first step is I need to define n, and we'll just do 10, 190. And then if I were to run this again, we're going to get 23. Is that correct? So if you remember back at the start, we checked it, and at the start it defines that the answer is going to be 23. So it looks like we're correct. Are we done? What else can we do? How else can we fix this code up? What have we defined before about our solution that we need to do to make sure that this fits all of the parameters that we defined up in the input, output, and additional issues? So Matthew says that we need to ask for a number. How would we go about asking for a number? So we're going to want to go ahead and throw this in a function. Oop. I'm just going to give it a quick little name. And that way we can reuse this. And we can just go ahead and copy all of this in. All right. Yep. Adam got it while I was typing it out, which is turn it into a function. So what else can we do to optimize this or clean it up or make it match the restrictions we gave ourselves up above? Anything else that we can do? So I think I saw somebody say that we were going to optimize it, and Valerie is correct that we also want to test it on multiple numbers. Same with Sanjay. So let's go ahead and actually run this code. So we know what the answer to 16 should be. So let's go ahead and do that one first. And we'll do the edge cases right around it as well, just to make sure that it's outputting results correctly. So are those results correct? So we know from the work we did above that the work is going to be correct, or the answer is correct. That at 15, it's not going to add in 15, and then at 16 or 17, it would add in 16 or 17. What else can we do to optimize this? How else can we clean up this code? So maybe we don't want to print it. Maybe we want to make it a bit more flexible and just simply return total. What else can we do? So one thing we can do, depending on what your code is doing, we can also just simply write this as a list comprehension, and then go ahead and sum the list. Ooh. Sorry, fat fingering. And I'm just going to go ahead and copy for speed. So we turn our function into a list comprehension. It's a little bit tinier. It's a little bit easier to understand. Well, maybe easier to understand depending on your opinion on list comprehensions. And I have an error I introduced. Anybody see the error I introduced on accident? Save me some time. Missing a colon on the error. I'm talking about here. Oh, you are correct. Extra set of square brackets. There we go. Nice job, Valerie. All right. So, anything else we could do to speed this up? Maybe a for loop isn't the best way to go about this. So, depending on what your end goals are, you might want to optimize for speed. You might want to optimize for space. So we can go ahead and do that. We're not going to step through that secondary solution, but so when we talked about way up at the top all of these different versions. One of these might lead you to the one I just copy and pasted in, which is that we want to sum all of the multiples below n. Then we want to do it again for 5, or sorry, multiples of 3 below n, and then we want to do it again for 5. And then we want to remove overlapping values and add those two separate summations together. The way to do that would be right here. So we can find the sum of a multiple below a given number, and then we can do that again for 5, and then we can remove out the duplicates before finishing it off. And that should give us not oh, that's because I have, there we go. All right, so we can optimize this thanks to just simple math. We just have a summation formula, and then we run that summation formula 3 times instead of touching every last number below n. So that would get into big O complexity, and we're not going to cover that topic right now, but there's different ways you can optimize and different ways to measure the efficiency. So finally, we're almost done. We have this answer. It's looking pretty good. It runs pretty fast. Now we want to break it. The reason we want to break it is because users are dumb. The computer is dumb. Somebody's going to break it, so it might as well be you. You want to break it before anybody else finds it, so that way you look good, and your code looks like it's always working magically. So give me some ways to break this code. We'll go ahead and say this code right here. So I'll go ahead and bring it down. How am I going to break it? All right, so Colette has the first idea, which is to just simply pass a string. So we're just passing something that is not a number. Adam says we can go ahead and pass a negative number. What else can we do? There are plenty of other ways that we might be able to break this. So we could go ahead and pass a float. So we're passing a number, but just like the negative, it's just not the natural number we were expecting. What else can we do? So Matthew came up with another idea, which is to go ahead and break it by giving it a really big number. So we want to pass it a number that is bigger than max int. And then what else? So we can go ahead and pass a bool. So we can go ahead and add that up here, which is just pass a non-number. All right. Anything else we can do? Yep. So what about just a function in general? How might we be able to break just a function? Ignore the code inside. So we might be able to, yep, so incorrect syntax would be one way of saying it, which is maybe pass nothing or pass extra parameters. So why would we care to actually break our code in these ways and with this behavior? It really boils down to what your code is expected to do, how robust it's supposed to be. That's a clever way to break it if you want to break your whole computer, Matt. Matt said, repeat the call to the point of overtaxing the computer. So we want to make sure that whatever our expected use case is, it passes for that. It also passes for any edge cases, such as a really big number, and that we've at least considered other ways to break it, even if we don't end up patching out those parts of the function. So we're going to go ahead and copy and paste those, and just so we can get an idea for what that might look like. So we can go ahead and change this one to negative. So with each of these, they're going to break in different ways. We can test some of them. The function should be robust enough to handle some of these. So if we give it -5, obviously 8 is not the answer we're looking for. Same with if we go ahead and I'm not going to run that one because it's going to take a while. Same with the 0 or a negative number. We can run that. It's going to give us an answer. It's just not going to be within the constraints. We can get errors. So we need to decide on whether these are worth fixing, whether our use case makes it valuable enough for our time. Your proctor for like a code challenge might tell you which ones that are worthwhile to fix, or might give you some extra clues as to how to we'd care to fix it or not. But if it's just your own code, it really depends on what you think is important, where your time is best spent. But generally, it should be able to handle all of your basic cases plus any edge cases, such as this really big number. So we'll go ahead and run that one now. And so we get an answer. We could go ahead and check that if we wanted to, maybe by comparing it against this one. Maybe we add in extra 9s along the way, just to see if maybe that breaks it. This particular case, it depends on what maxn is for Python, which I don't believe Python has any reasonable limit on what maxint is. So you can keep on going pretty far out with this. Finally is you want feedback and you want practice. I know practice doesn't help you with the problem you're currently banging your head against the desk on, but over the long run, that practice adds up. You start to see patterns. You start to learn that you've solved this problem before, or you've solved a similar one. You learn how to Google better, depending on what your issue is. And you also need feedback. That may be just showing your code to somebody else, pair programming, or if you don't want to talk to anybody, after you've solved it, Google how to solve it yourself. So go on, if it's a coding challenge, go on to whatever website you got the coding challenge off of and see what the solutions are there. See how other people have solved it, see what the most efficient way to solve it was, see what the answer that the coding site gave you. If it's not that, you might go to Stack Overflow and basically describe your problem to Stack Overflow and find somebody that's already asked that question and read what the folks on Stack Overflow showed you. If you just solve it your one way and then just never look at what anybody else has done or receive any criticism about what you've done, you're not going to improve. You're just going to basically stay at the exact same level of not being exposed to all these new ideas about different design patterns for your algorithms or anything like that. And then with the practice, just do it on the regular. The more you do, the better you get. And then finally, you're going to fail. You're going to come across problems that are either way out of your depth, or maybe they are just, you're looking at it from the wrong angle. That's fine. It's okay. It's normal. No matter what programmer you come across, I guarantee you they will tell you that a lot of the times their first solution does not work, especially for more complicated problems. It's all about iteration. It's all about trying different attempts, maybe looking at the problem from a different way, which is, it goes back to how you describe that problem in plain language. We got two different answers out of that plain language. And don't give up. Try the 20-minute rule, ask for help, and if you do finally say, I can't solve this problem, go to Google. Look at what other people have done. Find the individual parts of what your bigger problem is. See how people have solved those individual parts. Maybe it might give you an idea of how to best go about solving your own particular problem. Because failure is a part of the learning process. You need it in order to get better. If you're only ever doing problems that you're comfortable solving, then you're not going to improve. You're just going to stay inside your comfortable little bubble. So, any questions? So if nobody has any other questions, I will let y'all go. I did include some assignment problems if you want to go over them. Again, just follow the steps. I know some of these are going to be super simple, and that you don't need to follow every last little step, but building that habit is super important. If you're not following the steps on a simple problem, you're pretty much guaranteed not to follow the steps on a more difficult problem. So follow the steps, walk through it, try and avoid coding until you actually get to step 5. And if you fail, again, follow the steps for feedback, whether it's asking somebody else, looking at answers on Google. Don't just simply copy and paste this into Google and find the answer right off the bat. Actually try and attempt it and see what you can come up with. And then finally, if you want to practice, plenty of coding sites. Just included a couple here. If you want to read more about just how to attack a problem in a more methodical way, you can read about it here, or you can take a look at the video. All right. Well, if nobody has any other questions, thanks for your time, and see y'all later.